LangGraph implements dynamic execution control through interrupt-driven state persistence, enabling human-in-the-loop workflows by pausing graph traversal at arbitrary points while maintaining checkpointed context. The framework's interrupt primitive suspends node execution, serializes the current state via a configurable checkpointer, and surfaces the interruption payload through the interrupt field for external handling. We'll examine how this mechanism integrates with state management by constructing a 3-node approval workflow that leverages conditional routing based on interrupt resolution, demonstrating the complete pause-resume cycle using a memory-based checkpointer and thread-specific configuration. From typing import literal, optional typed dict. From LangGraph, checkpoint, memory import MemorySaver. From LangGraph, graph import state graph start end. From LangGraph, types import command interrupt. Class approval state type dict. Action details, SDR. Status, optional literal pending, approved, rejected. Def approval node state, approval state command literal proceed, cancel. Hash expose details, so the caller can render them in a UI. Decision equals interrupt. Question, approve this action. Details, state action details. Hash route to the appropriate node after resume. Return command goto equals proceed. If decision else, cancel. Def proceed node state, approval state. Return status, approved. Def cancel node state, approval state. Return status, rejected. Builder equals state graph approval state. Builder, add node approval, approval node. Builder, add node proceed, proceed node. Builder, add node cancel, cancel node. Builder add edge start, approval. Builder, add edge proceed, end. Builder, add edge cancel, end. Hash use a more durable checkpointer in production. Checkpointer equals MemorySaver. Graph equals builder. Compile checkpointer equals checkpointer. Config, configurable. Threaded, approval 123. Initial equals graph invoke. Action details, transfer $500, status, pending. Config equals config. Print initial, interrupt, hash interruptful u equals question. Details. Hash resume with the decision. True routes to proceed, false to cancel. Resumed equals graph. Invoke command resume equals true. Config equals config. Print resumed status hash approved. This code demonstrates a human-in-the-loop approval workflow using LangGraph's interrupt mechanism. The pattern shows how to pause graph execution at critical decision points, persist state, and resume with external input. The workflow is structured as a state machine with 3 nodes: approval, proceed, and cancel, where the approval node uses interrupt to pause execution and request human approval. The interrupt mechanism works by calling interrupt with a JSON serializable payload that surfaces to the caller in the interrupt field. When invoked, the graph saves its state using the configured MemorySaver checkpointer and waits indefinitely. The threaded in the config acts as a persistent cursor, allowing the graph to resume from the exact point where it was interrupted. When resuming, the command resume equals. Value becomes the return value of the interrupt call, enabling conditional routing based on the human decision. This approach is particularly useful for approval workflows, where human oversight is required before executing critical actions. The pattern demonstrates how to integrate dynamic pauses into a stateful workflow while maintaining the ability to resume execution with external input. The use of a checkpointer ensures that the graph state is preserved across interruptions, making it suitable for long-running or distributed workflows. However, it's important to note that the node restarts from the beginning when resumed, so any code before the interrupt call will execute again, which has implications for idempotency and side effects. Let's break it down. From typing import literal, optional typed dict.
imports literal, optional, and typed dict from the typing module for type annotations. Literal restricts values to specific literals. Optional marks a type as nullable, and typed dict defines dictionaries with fixed key-value type pairs.
From LangGraph, checkpoint, memory import MemorySaver.
Imports the MemorySaver class from LangGraph. Checkpoint, memory, which provides in-memory checkpointing functionality for saving and restoring graph execution states.
From LangGraph, graph import state graph start end.
Import state graph, start, and end from the LangGraph graph module. State graph is a class for defining stateful workflows, while start and end are constants representing the entry and exit points of the graph.
From LangGraph, types import command interrupt.
Imports the command, class, and interrupt function from LangGraph's types module, providing tools to pause graph execution and resume it with external input.
Class approval state type dict.
Defines a typed dictionary class named approval state that inherits from typed dict, establishing a structured type for dictionary objects with specific key-value pairs. This creates a type hint for dictionaries that will contain approval-related state data, enabling static type checking and IDE support for the expected structure.
Status, optional literal pending, approved, rejected.
Defines an optional field named status that can only contain one of 3 string literals: pending, approved, or rejected. This creates a type-constrained variable that enforces these specific values at runtime.
Def approval node state, approval state command literal proceed, cancel.
Defines a function named approval node that takes a parameter state of type approval state and returns a command object with a literal type restricted to either proceed or cancel. The function signature indicates it's designed to process an approval state and produce a command that determines whether execution should continue or be canceled.
Decision equals interrupt.
Calls the interrupt function to pause graph execution at this point, passing an object with properties that will be serialized and returned to the caller in the interrupt field. The function saves the current graph state and waits indefinitely for external input to resume execution.
Question, approve this action.
Defines a string variable named question with the value approve this action. That will be used as the prompt text for an interrupt point in the LangGraph execution flow.
Details, state action details.
Assigns the value of state action details to a key named details in what appears to be a dictionary or JSON-like structure being constructed. This operation extracts the action details from the current graph state and includes them in the output or payload, likely for surfacing to the caller or for use in an interrupt context.
Hash route to the appropriate node after resume. Return command goto equals proceed. If decision else, cancel.
Returns a command object that routes execution to either the proceed node if the decision variable evaluates to truthy, or to the cancel node if decision is falsy. This conditional routing determines the next step in the graph execution flow after resuming from an interrupt.
Def proceed node state, approval state.
Defines a function named proceed node that accepts a single parameter state of type approval state. This establishes a node function signature in LangGraph, where the function will process the current graph state when executed.
Return status, approved.
Returns a dictionary with a single key, status, mapped to the string value, approved. This represents a successful approval state in the current execution context.
Def cancel node state, approval state.
Defines a function named cancelNode that accepts a single parameter, state of type approval state. The function signature indicates this is a node in a LangGraph workflow that operates on an approval state object, but the implementation details aren't visible in this segment.
Return status, rejected.
Returns a dictionary with a single key, status, mapped to the string value rejected. This indicates the operation or validation failed, signaling rejection to the caller.
Builder equals state graph approval state.
Creates a state graph instance using the approval state class as its state schema. This initializes a graph builder that will manage state transitions and workflow execution based on the defined state structure.
Builder, add node approval.
Adds a node named approval to the graph builder, where approval node is the function or component that will be executed when this node is reached. This establishes approval as a step in the workflow that can be triggered during graph execution.
Builder, add node proceed node.
Adds a node named proceed to the graph builder, where the node's implementation is provided by the proceed node function. This registers the node in the graph's execution flow under the identifier proceed.
Builder, add node cancel.
Adds a node named cancel to the graph builder, where cancel node is the function or object that will be executed when this node is reached. This establishes cancel as a named step in the graph's execution flow that can be triggered to run the specified cancellation logic.
Builder at edge start, approval.
Adds a directed edge from the start node to the approval node in the graph being constructed by the builder. This establishes that execution should flow from the starting point to the approval node when the graph runs.
Builder, add edge proceed end.
Adds a directed edge from the node named proceed to the special end node, establishing a transition that terminates the graph execution when the proceed node completes.
Builder, add edge cancel end.
Adds a directed edge from the node named cancel to the special end node, establishing a transition that terminates graph execution when the cancel node completes. This creates a clear exit path from the workflow at the cancellation point.
Checkpointer equals MemorySaver.
Creates a checkpointer instance using the MemorySaver class, which handles in-memory persistence of graph execution state for LangGraph. This object will be responsible for saving and restoring the graph's state when interrupts occur, allowing execution to pause and resume while maintaining context.
Graph equals builder. Compile checkpointer equals checkpointer.
Compiles the graph builder into an executable graph instance, passing the specified checkpointer to enable state persistence and interrupt handling. The resulting graph object can now be invoked with thread IDs to manage execution state across interruptions.
Configurable, threaded, approval 123.
Creates a configuration dictionary with a nested, configurable key containing a threaded set to approval 123. This establishes a persistent identifier for checkpointing, allowing the system to track and resume execution state associated with this specific thread.
Initial equals graph invoke.
Invokes the LangGraph graph execution and assigns the result to the variable initial. This starts the graph's processing pipeline with any configured parameters, potentially triggering interrupts if defined in the graph nodes. The execution will either complete normally or pause at an interrupt point, returning control to the caller with any interrupt payload in the interrupt field if an interrupt occurs.
Action details, transfer $500, status, pending.
Creates a dictionary with two key value pairs. Action details, mapped to the string, transfer $500, and status, mapped to the string pending. This represents a transaction or operation that is currently awaiting processing or approval.
Config equals config.
Passes the config parameter to a function or constructor, likely configuring interrupt behavior in LangGraph by specifying thread persistence and checkpointing settings. The exact effect depends on the receiving function's implementation, but this line ensures the configuration is applied to the operation.
Print initial interrupt, hash interrupt value equals question. Details.
Prints the value stored in the interrupt key of the initial dictionary, which contains an interrupt object with a payload containing question and details fields. This line outputs the interrupt payload that was generated when the graph execution was paused, showing what external input the graph is waiting for to resume.
Resumed equals graph. Invoke command resume equals true. Config equals config.
Invokes the graph with a resume command and specified configuration. The command resume equals true parameter signals the graph to resume execution from a previously interrupted state, while the config parameter provides the necessary context, including threaded to locate and restore the saved checkpoint. This call effectively continues graph execution from where it was paused, passing the resume value back to the interrupt point.
Print resumed status hash approved.
Prints the value of the status key from the resumed dictionary, which evaluates to the string approved. This outputs the current status after resuming execution from an interrupted state. This implementation showcases LangGraph's interrupt-driven workflow pattern, where human-in-the-loop approvals are seamlessly integrated into a stateful graph execution. The core mechanism revolves around the interrupt primitive, which pauses execution at arbitrary points while maintaining checkpointed context through the MemorySaver checkpointer. The workflow's three-node structure, approval, proceed, and cancel, demonstrates how conditional routing can be achieved by resuming with a Boolean decision that determines the execution path. The threaded configuration serves as a persistent cursor, enabling the graph to resume from the exact interruption point. When the graph is invoked initially, it pauses at the interrupt call in the approval node, surfacing the payload in the interrupt field. Resuming with command resume equals true injects this value back into the node, allowing the conditional common go to equals to route to either the proceed or cancel node. This pattern effectively separates the decision logic from the execution flow, making it ideal for approval workflows where human oversight is required. The design choice to restart the node from the beginning upon resume has implications for idempotency, as any code before the interrupt call will re-execute. This trade-off is acceptable in this scenario since the approval node's only side effect is the interrupt itself, but it's a consideration for more complex workflows with pre-interrupt operations. The use of a memory-based checkpointer simplifies the example, though the narrative notes that production systems would typically use more durable storage for long-running workflows.
The checkpoint clutches the thread, while the interrupt dangles a question it will never answer.